Mr. President, dear assistants, Assalamu alaikum. My name is Rushdi Boujahan. I am a PhD student at the University of Kalma, and I am a proud member of the Labstick Laboratory. And today I will present you our work entitled LISP, the new pedagogical approach to learn mathematics in Algerian colleges. In front of you is the presentation agenda. First, we will start with the introduction, followed by our problematic. Then we will present the state of the art, which is divided into two parts. The first part is about proposed approach, and the second one is about realized system architectures. After that, I will present our proposed approach, which is called LISP. Then I will present our system architecture, which is called M2M. Finally, a conclusion and future works, and of course, some references. Before I begin, I know that for people who are not familiar with e-learning, it seems quite very far from computer science. We call it social informatics. It's a combination between computer science and psychopedagogy. It's about using the ICT, information communication technologies, to use these technologies to assist learners in their job to give education context to their learners. This is just... as you know, the education level of any given nation is a major indicator of its progress and well-being. Developed countries are always elaborating new curricula and integrate them with new technological forms in order to make the learning much more easier. In all over the world, mathematics should be learned from the earliest ages and continued up to the university, where it is fundamental to other multiple disciplines such as computer science, physics, chemistry, finance, etc. Therefore, it is highly required part of the curriculum of any student in any university. Unfortunately, learning mathematics is not an easy task for a lot of learners. In Algeria, for example, languages and mathematics are the most challenging courses for college students, according to our Ministry of National Education. Lots of reasons can be behind these facts. Some of them are of pedagogical nature, such as teaching techniques. Others can be technical, such as the teacher's training. So, our main two questions here are: what are those difficulties that our college students are facing when learning mathematics? And second one is, how can we benefit from the accelerated technology advances to improve mathematical learning? In order to answer previously asked questions, we have led a field study. So we start our field study by a set of questionnaires given to both students and teachers. As you can see here, some samples of the questionnaires. This is one. This questionnaire is given to students. This one question is: do you like teamwork? Yes, no, a little. And you can see the results. Here is another sample. Do you know how to use computer? Yes, no, little. Which lessons you find hard? Algebra, geometry, or both? And here is, you can see a sample of questionnaires given to teachers. For example, here, do you give homework to your students? Yes or no? The other side of point of teachers which are more difficult, algebra or geometry, and a lot of other questions. Information gathered with was quite helpful and gave us some answers about the first posed question. A lot of reasons are behind low results in mathematics in our colleges. For example, the failure to manage several pieces of information at the same time, failure to remember relationships, inability to apply mathematical rules and standards, lack of organization, failure to follow instructions, failure to understand what is required of them when solving problems and exercises, confusion in their thoughts. We then conducted a literature search about works conducted to resolve similar problems. Among found works, we can cite the work of Munoz Arriaga, who proposed an architectural model for the implementation of a graphical user interface for mobile application, particularly for basic mathematics. It was focusing on students between 6 and 12 years old. One proposed to use a digital pen-based learning system with a collaborative problem solving to improve the learning outcomes. Wood proposed an approach, he called it RTL, where reading, thinking and learning is the main curriculum for students. The main idea is that once a week students choose a subject of interest that is a level higher than their grade, then they must read and think on the same subject, so they learn it. And about realized architecture. So these are architectures that are realized and were available for students. We can cite MathCityMath, MoMaMath, which is based on Mathematica and Web Mathematica, Intelligent Web Teacher. So, here at the stage, we start to propose our new approach. But before we pose our proposed approach, we must fix its goals. Our proposed solution must be able to, first, make the process of learning mathematics much more easier for students of middle school, while respecting all steps already involved in conventional classrooms. We call it LISP. LISP stands for Learn, Imagine, Select, Practice, and the second P between the brackets stands for Play, which is an optional option. Learn by reading the content of a set of concepts. So the student will learn a set of concepts. Then he will use his imagination to link them to the real world. Then he will identify and select his needs to learn and share with their peers, teachers, and so develop his knowledge. And after that, he will practice learned concepts through the resolution of exercises. And after that, he can, it's an optional option, play educational games in order to master learned concept. So this is our model, please. First stage, learn. The student must learn concept presented by the teacher. Teacher chooses the content of the concept associated with the knowledge. So the teacher is, when we call teacher in in e-learning, the teacher, we mean the course designer, the one who is designing the course, and we differentiate with the learner who gives the course. So in our college in Algeria, courses are divided to chapters or pairs. They call them pairs, and teacher must meet the following conditions: relevance, realism, and simplicity. After that, he will use his imagination. Imagination can be of two kinds. The first one is scattered imagination, which leads the student to daydreaming. The second one is creative imagination, which leads the student to draw a painting, compose a poem, or solve a problem. Teacher himself must use a lot of imagination to give creative, imagination to the student. The select phase. A student is offered a range of options, optional questions, graphics and geometry shapes or puzzles, and he will pick what is appropriate for his imagination. After translating reality into mathematical equation, methods, and symbols. The fourth phase, which is practice, can be done in two phases. The first phase is to give the students simple exercises, or what you can call them the direct application or direct exercises. They are the direct application of the lesson, requiring the direct use of the topic to be solved without any difficulty or thinking. The aim is to strengthen the use of the topic. Second one is the is indirect exercises, which can be more complex exercises that requires the resort for the formulation of the questions in such a way that it can be applied directly in our everyday life. A common example of these exercises is complex mathematical problems. For example, in the school, Ahmed goes to the souk and he bought some oranges. How does he spend the cost? What is the cost of the oranges he bought? Then he can eat 3, for example, oranges. How many oranges he will have? So, the fifth optional phase is the play. At the first stage, we started the fifth stage as permanent. We thought at the beginning that games, in learning we call them especially serious games, that will be very beneficial to the students. But in the field, after we see our field study revealed that games are not always suitable for learning. So educational games are designed to help students to gain certain skills and develop their communicative skills as well as to increase their interaction with the environment thought. But like I've said before, our field study revealed that games are not very beneficial in learning mathematics. Our system architecture, our system includes a set of tutorials in both text and video formats with series and exercises that can be with or without solutions. It offers options that allow the student to study mathematics in a fun and not boring way by including educational games with it. Here is our realized architecture. We call it M2M, mathematical for second year, middle year. Here is a screenshot of our realized system. You can see that we designed it with an Arabic interface, where middle school year student can enter at this platform and use our approach. Here is another screenshot. When we use the course is divided into pairs. Unfortunately, we were not able to realize a real test at the field because of the last year incidents and the Iraq and all this, and so our application remains always without any tests. Our new proposed method list is made of a set of steps covering all the learning phases on a pair of a subject. During the implementation of the system, we also associated a different color for each phase. This makes it easier to adapt the method. Our system, called M2M, is intended to be a support tool and not a substitute for the classroom teacher. This system is a tool that supports and strengthens students' knowledge. Our system has several advantages. It supports the language of instructions, which is Arabic. It offers a range of educational and recreational activities that allow students to increase their levels of mathematics knowledge. It offers a set of exercises to facilitate the acquisition of different concepts related to the content of the material. And lastly, it supports collaboration between students organized in a small group. As I've said before, we are not able to test this system. But as perspective, we intend to test this system this year, inshallah, or another year. Thank you. Here is some references that I use.
Thank you, Mr. Bouchard. Any questions from Mr. Foresti?
I thought there will be any.
I have a question. If you can test your system,
yes.
What are the metrics that you would use to validate to see if your system is suitable for students?
The domain of our the education, the e-learning domain has its own rules, its own standards. We have a lot of tests, a lot of norms that can be used to test. But the main and the obvious result is the enhancement of the student marks and their involvement, because in our e-learning and education in generally, we fight what we call the learner isolation, and the learner isolation is a very big problem. When the learner is isolated, he will not interact with the teacher, he won't interact with his colleagues, he has not the motivation to learn. So in e-learning domain, our first mission is to find those learners who are isolated. So a teacher, for example, with 40 students, he cannot treat them one by one. But by using new technologies, ICT technologies, he can pinpoint which are students or learners that have difficulties, and better he can pinpoint what are those difficulties. And so he can intervene at that time and help those learners.
Salam. Ma question c'est en relation avec les premiers transparents, là où il y a la constatation sur les statistiques faites par le ministère qui disent que nos enfants ont deux problèmes, un problème de langue et un problème de mathématiques. J'aurais aimé que la dame spécialiste en linguistique reste ici, parce que tout à l'heure elle nous disait qu'il n'y a aucun problème de l'apprentissage des langues. Et là vous dites que, bon, en algérien, language, problème de langue. C'est le problème les langues. Il y a un problème de langue. C'est dommage, la spécialiste avec parce que tout à l'heure elle nous disait qu'il n'y a aucun problème, que ça pose. Et là, donc chez nous c'est un problème énorme, c'est les constatations du ministère. Le ministère il nous dit qu'il y a des problèmes, il ne nous dit pas pourquoi ce problème, il ne propose aucune solution. Donc c'est juste pour dire qu'il y a une alarme sur l'apprentissage des langues en Algérie. Je donne un exemple, juste les vieux Zawada, les anciens, ils parlaient l'algérien pur. Ils pensent algérien et ils parlaient l'algérien pur, avec aucun mot en français, bien qu'ils étaient colonisés pendant un effet, ils parlaient un langage, les jeunes d'alors qui parlent arabe, français, un langage qui n'a pratiquement, en Kabylie c'est pire, ils parlent arabe, français, kabyle.
Berbère, c'est un mélange entre le kabyle et le chabyle.
Oui, mais bon, la langue berbère, c'est une langue. Les vieux, ils parlent le berbère, il n'y a pas aucun mot arabe, aucun mot français. C'est pour dire qu'il y a un problème. Les seuls qui échappent à ce problème, c'est les enfants qui apprennent le Coran. Ils apprennent le Coran.
Parce qu'ils apprennent les linguistiques.
Non, je parle de langue, pas de la prononciation. C'est pour dire que Hadouk n'a aucun problème de langue. Donc c'est juste pour dire, pour contredire la dame qui disait qu'il n'y a aucun problème. C'est pas très dit.
Pour être juste sur la question sur les déclarations du ministère, donc ce sont des déclarations dans les journaux, dans les médias. Ce n'est pas des statistiques officielles parce que malheureusement notre ministère n'a pas des statistiques qui sont publiées comme par exemple aux États-Unis ou aux autres. Mais je vous contredis sur le point que vous avez, quand vous avez dit que le ministère n'a pas pris n'a pas pris de pas pour résoudre ce problème. Il y a trop de réformes parce que quand on est sur le champ, sur le terrain, quand on travaille avec les enseignants sur le terrain, le ministère a pris la décision de faire plusieurs réformes. À l'occurrence, ils ont fait des stages pour les enseignants du primaire pour les mathématiques. Parce qu'ils ont appris que, par exemple, les enseignants, un enseignant par exemple qui est licencié en lettres arabes, il n'est pas forcément fort en mathématiques. Donc ils ont commencé, donc peut-être l'année passée, peut-être l'année avant, les enseignants font des stages chaque semaine, chaque samedi je crois, avec les mathématiques pour résoudre ce problème de mathématiques. Pour les langues, je n'ai pas d'informations. Mais il y a un problème, le ministère le connaît et l'approuve et elle prend des réformes pour résoudre ce problème.
Une autre remarque. Oui. Sur la dernière, tu parlais de la dernière étape, le jeu. Tu disais que ce n'est pas très important le jeu.
Je n'ai pas dit que c'était pas très important, j'ai dit que c'est pas toujours intéressant. On fait ça en France. Ça dépend du jeu. Il faut toujours. Les jeux, c'est un outil.
Il faut choisir les jeux.
Justement, il faut choisir les jeux. Et là, on parle de notre petite expérience avec notre échantillon, du jeu, avec notre échantillon. Peut-être que le choix n'était pas bien choisi. Il y a trop de jeux. Moi, avec ma fille, je cherche. Il y a des jeux sur Internet qui pour apprendre l'alphabet, pour apprendre les mathématiques. Il y a des jeux. Mais le problème toujours, quoi choisir et oui,
parce que les plus grands spécialistes en pédagogie disent que les meilleures méthodes d'enseignement, c'est avec le jeu. C'est en jouant avec le langue. Bon, malheureusement, chez nous, à l'école, il y a des jeux, c'est une catastrophe.
Oui, ça c'est pas le problème, c'est avec les enseignants. Les enseignants ne maîtrisent pas les TIC. C'est un grand problème que souffrent la plupart des enseignants. Ils n'ont même pas des machines et ne savent même pas comment imprimer. Mais ça va venir avec le temps. Peut-être, Inch'Allah, que ça s'améliore.
Merci,
monsieur le prochain. La prochaine présentation sera par Rosane. Le deuxième auteur. Le deuxième auteur, c'est Hamza Boussir.
Voilà, elle est intitulée Geometrical Characterization of White Stitching fabric using image processing technique.
Assalamu alaikum, bismillahirrahmanirrahim. I am Hamza Abubisir. I am a doctor in civil engineering from TBC University. I would like to thank the scientific committee of this conference for accepting our work titled Geometrical Characterization of White Stitch Jute Fabric using Image Processing Technique. This work was done in collaboration with our colleagues from Tunis and Manar University. The PRISM work is the first attempt to use image processing technique in order to characterize jute fabric to facilitate the assessment of its convenience as reinforcement for composite materials. The use of materials in human life is as old as time. During his search for a more comfortable life, man invented new materials satisfying his daily needs, which resulted in creating the group of materials referred to as composites. The composites are the best materials meeting the requirements that other materials can hardly achieve, which allow them to be a field link in almost all scientific issues. Without fiber-reinforced composites, modern aircraft production would not be possible. Synthetic fibers are by far dominating the reinforcement of composite materials. However, they present many drawbacks because they are expensive and they are harmful for the human health. Plant-based reinforcement have been presented as a good replacement for conventional synthetic fibers. Emphasizing the green technology can save our future generation. In recent years, plant-based reinforced composites have got great attention as they enable us to easily fabricate lightweight components at affordable cost from eco-friendly renewable resources, leading to a construction material endowed with lower density and manufacture costs. In the last decades, in order to minimize time, labor, and economize money, the textile field made use of digital image processing techniques in order to establish fabrics parameters recognition. Nevertheless, vegetal fabrics was not sufficiently studied as part of this recent tendency. The investment in automated fabric parameters investigation is more than economical when reduction in labor costs along with an accuracy improvement are considered. In the present study are trying to make a contribution to the identification of jute fabric's geometrical characteristics by applying the digital image processing techniques, while avoiding wastage of materials, and all at once without invoking expensive tools available in Algeria. For the best knowledge of the authors, the aim and purpose for this research paper was not published elsewhere. In this study, a quasi-balanced 2D jute fabric was investigated, as shown on the figure 1. Normally, the numerical framework validation. Normally, experimental results are used to validate the numerical data. That is why an experimental campaign was carried out with the aim of obtaining the actual values. Concomitantly, digital image processing techniques are carried out on the jute fabric for the purpose of analyzing its geometrical characteristics. The digital image analysis of two-dimensional image is based on the image requirement. Consequently, its description will be done by a two-dimensional matrix presenting a different number of bytes. Firstly, the images elaborated from the fabric are converted to grayscale. Secondly, quality enhancement is applied to the grayscale image through performing some noise and image smoothing filters, which allows the extraction of some useful data. During image quality enhancement, numerous operations are carried out. Among them, change of the grayscale level, system and contrast improvement, edge exposition, improvement of sharpness and decrease in the noise level. Defining a threshold, its principle is changing the values of brightness function of the particular image pixels. Filtered images were converted to binary form consistent of O and Y. Yarn count depends on the diameter, length, and density of each yarns. Counting yarns using pixie counter result in 6 yarns in the warp and 4 yarns in the width direction per 2 centimeters. The same values were obtained by IPT, which is presented in the squares. Cover factor is defined as the ratio of the area covered by the yarn to that covered by the fabric. The analytical calculation of the fabric cover is done following the equation below. Using this equation, we have found the following values for fractional warp, fractional width, and total cover factor of 50%. Direct determination of fabric's cover factor by image processing is carried out as a ratio between pixels of yarns and voids. These steps lead to a total cover factor of 50.44% with a difference equal to 0.49%. Thus, we maintain the same parameters used in terms of resolution, grayscale, threshold, and quality enhancements filters in order to determine geometrical characteristics requiring experimental tools available in algebra. Cross-sectional area of yarns. Natural fibers present no uniformity in their cross-sectional area. That is why the conventional simple measurements cannot achieve sufficient value of precision. In our study, we made use of IPT in order to determine jute yarn's cross-sectional area. IPT was used to highlight the outlines of cross-sectional views on the micrographs obtained by the microscope and to determine the most accurate value. The average value was 1,374 square micrometer, which is within the interval of jute yarn's cross-sectional values published previously, as shown on the figure of distribution of fiber cross-sectional area for jute fibers. Yarn spacing is describing the distance between the two consecutive yarns in the same direction. The calculated values using image processing techniques are shown on the figure 6. The values are 2.12 millimeters in the warp direction and 1.4 in the weft direction. Fabric thickness is defined as the distance between the two fabric surfaces. It is difficult to calculate the actual fabric thickness because it's greatly influenced by the pressure exerted on the fabric. We used IPT to determine its value more easily. The value obtained is 0.90 millimeters. Hairiness is indicated the amount and length of fiber ends and loops protruding from the body of the yarn, imparting a fusy appearance. This was done in 4 steps. Firstly, the image is rotated to be in a perfect horizontal plane. Then the image is cropped to show only the yarn and its hairs. The yarn's core is removed by dilation, and finally counting the hairs number and their length. We have obtained 24 hairs having more than 3 millimeters, which lead to 266 hairs in 1 meter of yarn. The total cumulative length of hairs in our study leads to H equal 4.53, which is an inferior value than H index previously published. Yarn wavelength. It was not possible to measure the yarn's wavelength with the experimental tools, so we used IPT to define its value. The wavelength in the fabric is the distance between two consecutive crests in the same principal direction. The values are 8.5 millimeters in the warp and 7.8 in the weft direction. Yarn linear densities mean the weight per unit length of the yarn equal to 1 meter. The analytical equation is below. The mean value of the analytical equation is 373 and 408 text for warp and weft direction, respectively. From these values, we can calculate the mass per unit area using this equation, and then by the exploitation of the data obtained through the IPT, using the count test data, 1 square meter of the fabric would be constructed of 300 warp and 225 weft yarns, thus leading to fabric mass per unit area equal to 204 grams per square meters. This value need to be checked through experimental investigation of the fabric mass per unit area in the next section. The experimental investigation gave the value of 202 grams per square meter. That is only 1% different of the value achieved by IPT. This fact confirms the efficiency of the IPT approach used in the prism work. Conclusion. The prism work is mainly concerned with the use of image processing technique for the identification of jute fabric's main geometrical parameters. This approach, previously applied for cotton and wool fibers, gave the possibility of determining fabric's main geometrical characteristics with satisfactory values and satisfactory differences. The greatest advantage of this approach is the fact that the values determined using image processing method are obtained more easily with practically no trials carried out, without any materials wastage, and with a sufficient accuracy, and especially without using expensive tools available in Algeria. According to the accuracy extent of the numerical values, the prism work could be considered very promising for future use in the valorization of all natural fibers-based fabrics in composite materials. And thank you for your kind attention.
Mr. Bougane. C'est Bouxir. Le deuxième. Second author, Hamza Bouxir. Very question. I have one question.
Yes. You used your gray scale, right? Gray scale.
Yeah.
Maybe your image, if your image, color scale, what do you do?
No, the image was converted into grayscale so we can extract the filter that we need. No, it was color. Then we converted it in grayscale.
What do you mean by using image processing tools? What are the image processing softwares you use?
Yeah, the software used was Photoshop, and we we have used a script consisting of determined resolution, grayscale, some filters for noise and smoothing. Aims. It was a collaboration between us in the civil engineering and the computer science.
Is there any programs developed or written programs?
This is the final aim of this work. So we have done 2 papers.
Yes,
for
because
two materials, and we aim to make an algorithm.
Yes, well, d'habitude, en informatique, we analyze the situation and we make modelization, and then when we go to implementation, we programming. And if I understood your work, you take image and you analyze them by using Photoshop.
Yeah.
Yes. And you say that you can extract characteristics without using other chemical tools or
other mechanical tools.
Mechanical or chemical. Yes.
Yeah. What I am saying this because I have passed almost 3 years during my PhD in order to find the tools, necessary tools, in order to characterize my favorites.
Yes.
So it took a lot of time, a lot of money, and it was labor, great labor, to make it possible. Then we have searched in the literature, and we have found that there is publication about the use of IPT on wool fibers to extract their features. And we have applied these techniques following the work done by Durbani. It's cited in the references. And we have calculated a lot of parameters.
You have calculated them manually?
We have calculated them manually and experimentally, and then
I'm talking about computer science. On computers, how you analyze the image? How you calculate this distance in the image? By program or algorithms? There is no algorithms that they are.
I'm not specialist in
informatics. You say that
what I am
work is combined of two
specialities.
Two specialties. Computer science and
civil engineering.
Yeah. But I don't see computer science part in your here.
I didn't understand. Sorry.
The computer science part of the work.
The image processing.
How do you noise, for example? How do
you don't
yeah, they applied the filters to clean noise.
You don't understand what our specialty.
Yeah, exactly. That's the point.
In our specialty, computer science contribution is proposing a modelization and a general system on general modelization and then implement and produce software that can be applied on all kinds of images. If you have a software where we can upload, open an image of your
favorites,
and the software give directly all characteristics. Is there?
Yeah, I have understood this point, but what I have said that this is the first part.
The first part.
Yeah, the first part of the work, and then we are aiming to make it in.
Thank you, Mr. Hamza. This is what certificate of participation. Thank you. The last presentation is Fleha Mazouj. I changed They changed the presentation. فرحة الزوج is there. The last one.
السلام عليكم.
فرحة الزوج represent paper entitled Language Modeling Based on Arabic Algerian Orally Dialectical Corpus. Arabic Algerian Orally Dialectical Corpus. The last one.
Today.
Yes, it's the last presentation. Tomorrow. Yes. He's absent. He's not here. Last one is absent. Last one.
السلام عليكم. So I am present myself. I am Zouj Freha, from the University of Shlef. I am here in order to present you our work about language modeling based on Arabic Algerian Orally Dialectal Corpus. So, good morning for everybody. Our outline is presented. We start with the first introduction. Second, we speak about some related work. Thank you very much. We speak about some related work in the context of corpus or collect of corpus of our dialects. 3, we speak about Algerian dialects, and especially about the Orani one. To introduce our approaches, some experiments are presented, and finally we conclude. So, the modern standard Arabic, called MSA, is a formal language used in the Arab world, especially in Algeria. But unfortunately, it's only theoretical. In the reality, the Arabic dialects are used in the everyday matter of communication, such as everyday life in the social networks, in the movies, and so on. Our investigation is in context. First, we have contributed to collect a textual Arabic Algerian dialectal, Orani version, dialectal language modeling, the first processing we have done on our textual collector, and finally we have tried to enrich this Orani dialectal language model using some MSA language model based on topics. Investigating in the dialect languages need some resources in spoken or written for the languages. As related work, we present the work done by Silwani and his collaborator. They tried and they collected some corpus, Algerian corpus, from standard Arabic Algerian, affected by the dialect speaking by the locator and the speakers. Important works are done by the Professor Smaili and his collaborator. They collect Arabic dialectal for 5 dialectors, non-PADIC. Also, Green and Orl and its collaborator have tried to collect 2 dialectal Arabic Algerian. Jalab and his collaborator have collected an MSA language corpus from telephone conversation. However, the language Arabic Orani dialector must still until now under-resourced. I note that investigating in spoken in Arabic dialector can apply is useful for many other applications, directions of applications. First, spoken of textual Arabic dialect identification, Arabic dialectal machine translation, dialectization in Arabic dialect, Arabic dialect word segmentation, dialect language modeling, and so on. Let's speak about Algerian dialects. The Algerian Arabic Algerian dialects are basically based on, in terms of vocabulary, in lot of classical Arabic words, in different language Berber varieties, and also in original or code-switched words from French, Spanish, or Turkish. As example, we have some words. As Kursi is taken from Arabic. Fartoto is taken from Berber varieties. Fishta is taken from Spanish vocabulary. And Qahwajika, for example, is taken from Turkish language. The Orani dialect is the important spoken Western Algerian dialect from Aintmushent and Tnes, Fushlef. It is between affiliation in the literature because the use of Ga and Stayt Qa. In his letters, he takes all the MSA letters plus P, V, and Ga, which are not Arabic letters. For example, we have taken here some examples about some typical vocabulary for Orani. Perhaps we find girl, we tell it Shira for girl. Please, we said Hambouk, which it means God bless your father, but this meaning is hidden and you use it in order to say please, and such on. So our approach is first to collect an Orani textual corpus. Our procedure was, we have taken the PADIC Algiers corpus, where we found Algiers dialect and the Anabi dialects, and we have tried to translate it manually because we haven't a resource until now in the literature. We have translated in the Orani version. The second step, we have tried to modeling these textual data, each one with using both segmented and non-segmented texts. Third, we have interpolated the dialect language model obtained with MSA, Modern Standard Arabic Language Model, based in some topics. What is the language model? The language model is an important component in many automatic recognition systems, such as ASER, automatic speech recognition systems, machine translation systems, machine comprehension systems, and it's also an important file in the NLP, natural language processing, and so on. The language model is based in the Gaussian assumption that if we try to take the probability of a sentence, it is the probability of each word according to the word before of this specific word. So we don't take in consideration all the math words, we take only the first or the third or the three occurrent words, and we name this 1 engram, 2 engram, and 3 engram. As a matrix, we use a perplexity to compare another language. If we compare two language models, the language model with the best or the low perplexity is the best one. Other techniques we have used is the language model interpolation. We have a high-performance language model is generally trained using a textual corpus close to the target task, and another corpus or many other corpora. Our experimental are based in some data set, so the dialectal corpus, which we have collected in our group. So we have tried to divide it in training data, in development data, and test data. First, we have used it as raw data, and after we have used it after applying some segmented processing. Also, we have used MSA corpus found in the literature. We have taken two topics, many topics, but we have focused in these two topics about science and technology and religion. Our experiments, and in our experiments, we have used Farasa segmenter. We have found some modules, some programs, which enable us to segment our phrases using pronoun and the noun such as, so on basic on part of speech. A CLLM toolkit, which helps us to compute the probability and to generate the language models, and some shell and Perl scripts. So our experiments, in our experiment, first we use the raw Arabic dialect data, textual, without any morphological processing to train the language model. And we obtain the first result using the raw data, so our perplexity was bigger. Secondly, we applied the segmentation, called tokenization also, steps on the whole data and retrain our language model, and we found that our perplexity is better. In the second step, we have interpolated the language, our dialectal language model, each time with a language model from Arabic, training our language Arabic MSA on some data, textual data about economy, religion, sports, science, technology, and music, and so on. The obtained results are about the perplexity for the development and on the test data. So, this work was done in order to, because basically we have, as an important remark, we have modestly contribute first to create as conclusion I said, we have modestly contribute to create resources for Orani dialect. Also, we have modeled this data using engram and 3-gram language model. Also, the idea, what we have as problematic is any dialectal discourse or text of any Algerian, Orani, or Algerian general speakers could contain some MSA words, vocabulary, and vice versa. When we speak in MSA, we include some dialectal words in our discourse and our written, etc. So the MSA language model, which matched better with the dialect language model with our data, selected data, was the science, technology, and the religion. So, as perspective, we plan to enhance the Orani dialectal corpus size, or to explore other ways to model the dialect language model corpus using an NLM, neural network language model, or an NLM, recurrent neural network, or other deep methods for modelization of language. This work is the first step in order to enhance an automatic speech recognition system for Arabic, Algerian, And thank you. I am ready for your question.
Thank you. Thank you, madam.
Merci.
Any question? Last question. This is. Thank you.
Thank you very much.
Thank you very much.
Thank you very much.
Thank you.
It means I was clear or I...
That means that
It's late.
I am no specialized here in your field.
Thank you very much.
Les conférences, c'est un intérêt.
Oui,
C'est pas parce qu'il y a واحد.
bien sûr.
Surtout à cette.
J'espère que j'étais claire.
C'est toi
Voilà, exactement. Même la radio. Je vais...
message.
Merci beaucoup. ميرسي بوكو شكرا يعطيكم الصحة بارك الله فيكم أستاذنا بالتوفيق هذه ثاني مرة يحضر معي الأستاذ حضرنا في بالعباس وغا نخافا بريمينير اي سي اوسي دو سيبور thank you very much. Oui, on a créé du texte, on a ramassé du texte pour faire un corpus textuel. هذا on va le planer à le recorder pour faire du speech en parallèle. رانا نديرو la partie textuelle. On va exploiter la partie textuelle. Textuelle. واحد اللهجة العبرانية ورانا درنا واحد l'écrit. الحمد لله وضعك داخل واد داخل. هذا après on interpole avec du MSA avec الويب حتى حنا في الديسكور تاعنا على on utilise pas du MSA. Même كي نكونوا مثلا في التعليم ولا نكونوا في des situations formelles, on introduit toujours du dialecte. Donc si on interpole ces deux modèles de langage à base de arabe standard et dialecte, le système va reconnaître mieux. Quand on appelle le MSA, on va trouver un vocabulaire déjà, il ne va pas se trouver. Quand tu vas merger les deux, ça va aider pour la... On a déjà bien. renforçant le record in order to have a speech. Merci.
C'est bon, présenté.
thumbs up.